Welcome to Forging the Future, Decarbonizing the Steel Industry, a Hatch podcast series. I'm your host, Takshi Sachdeva, and invite you to join us on a journey through the challenges and innovations in iron and steel production. Discover how Hatch's century of expertise is shaping a sustainable future for the steel industry. Stay tuned as experts from Hatch share their insights on technology, market dynamics, and the path to decarbonization. Welcome to Forging the Future, Decarbonizing the Steel Industry, a podcast where we talk about the latest in sustainability and innovation in green steel. Today, I have Paul Towsey, Global Director of Iron and Steel at Hatch, and Gino a climate change specialist at Hatch, join me on the podcast today. Welcome, Gino and Paul, to the show.
Great to be here, Takshi. Thanks, Takshi.
So let's start with you, Paul. Today, you've been with Hatch for over 2 decades now, starting off as a process engineer and now leading the Iron and Steel Group. Can you maybe start off by telling us a bit more about Hatch and some of the projects you've been involved with?
Yeah, thanks, Takshi. So, love to talk more about Hatch. We're a team of 12,000 professionals who are guided by the vision in our manifesto of creating positive change. We do this by partnering with our clients to develop and execute projects. That's fundamentally what Hatch does, is execute great projects that are both sustainable environmentally, which is going to be important in the subject of what we're talking about today, but also economically. It's really important that the projects that we develop are profitable for our customer. Our customer needs to make money, and that allows them to solve the challenges that they need to solve as they move on into the next few decades.
Yeah.
Our team here at Hatch is focused on driving that value right through the value chain. And we do this by doing our homework and ensuring that the right technologies are selected and the right solutions are generated given the constraints of that customer in its jurisdiction. In green steel, this involves the entire value chain, right through from mining through to finished products that are delivered to that steel company's customer.
So what types of projects and industries does Hatch work in?
So we work for all the major resource companies and iron and steel companies. The type of projects we do for them could involve developing brand new green steel projects where we work all the way from the concept phase, where we look at all the different options they could work with. We select the best one, and then we carry that forwards through into the development phase and finally into the construction phase and startup phase. We also really excel in brownfield projects. Where safety and operational interruptions are something that's a critical aspect to that project's or those type of projects' success. Within our team, we've got 50 dedicated subject matter experts that cover all of the different processes within the iron and steel value chain. And many of these colleagues have an operating background that truly helps us to think like owners and understand what's important to an operator.
So I'm glad you touched upon Hatch's involvement with green steel projects. I mean, we've been hearing the buzzword green steel, especially when it comes to decarbonization of the industry as a whole. What does green steel mean to Hatch?
So before I answer that question, I'm going to give a little snapshot of the steel industry today. So of the 2 billion tons produced today, about 80% of that is made through the smelting of iron ore using coal. That's done in a route that we refer to as an integrated plant. It has the blast furnace at the center of it, and the blast furnace, while extremely efficient, does not have a pathway to eliminate the use of coal. The balance of steel production is made through the recycling of scrap metal. It's done through melting that in an electric arc furnace or an EAF. In the process route that's known as the mini mill or the EAF route. That process has comparatively very low emissions compared to the integrated route and has been widely adopted in certain markets. So it's not new, it's not novel, but it is widely adopted in markets such as the US, but around the world really hasn't been proliferated to the same extent. Steel demand is forecast to grow over the next couple of decades. As emerging economies continue to develop, the amount of steel consumption is going to increase. That can't come through the recycling of scrap metal. It has to come from new steel being brought into the market. And so green steel or low carbon steel has to be the solution to making that new product to the market. So back to the question around green steel, it's not, in Hatch's view, that's not a product. It's a concept. Any project that we're involved in that involves the reduction of carbon dioxide per ton of steel produced is what we call a green steel project. And so we bucket those together. And those projects can involve deploying new technologies to make incremental changes, or they can involve the complete replacement of blast furnaces with new technologies. Those new technologies are going to need green energy, hydrogen, natural gas, biomass, all the availability of stuff like carbon capture. And there's a lot of technologies coming into the market. There's more and more technologies daily. And that's where Hatch plays a role as a trusted advisor to help our clients navigate all of these new technologies and help them really select the ones that are most applicable for their application.
I think it's worth going back to that, concept of green steel. There's a lot of, anytime you're on a panel discussion or listening to a podcast, they might start with what is green steel. And if there's one thing people can agree on in climate, it's that they don't like the phrase green steel. And part of that is like a bit of a lack of definition in what it actually means. And it opens up a lot of arguments. From our perspective, when we think about green steel, it's useful to think about the context. And this could be, the steelmaker themselves, whether we're thinking about policy or looking at investors and customers and what their expectations are. So while I think it's hard to say what is green steel and define it very clearly, in an individual project, it's worth thinking about, okay, for this client, what does this mean? So if I'll take a steelmaker as an example, if you're doing a green steel project, you need to look at their objectives. Are they trying to avoid compliance costs that are continuing to increase? Are they trying to meet specific procurement requirements? For example, those under Buy Clean California, or maybe under some of the voluntary frameworks, like some of the commitments that automotive customers are making with respect to their steel purchases. From a policy side, which drives a lot of this activity, it's sort of two things. It's what's the current policy, and also where do we see that policy headed? And when you're looking at any of these green steel projects, you're not making a project that's going to be this year only, and then you get to change it every year to meet tomorrow's reality. You need to look at the policy's expectations over the life of that project and make sure you're considering that in the overall business case. On the customer end, this one's sort of interesting because, everybody's hoping that a green premium will emerge, but it's really hard to envisage that happening without some sort of level of policy support. But customers are saying, here's what we want you to disclose, here's how much low emission steel we're going to buy, and this is what it looks like. So you got to take all of these things together when you're looking at a green steel project. And while it's hard to define it in a broader context, you should make an effort to define it for a specific project or for evaluating a specific business opportunity.
No,
I'm glad you brought up green steel premiums there. Gino. I was listening to an excellent podcast the other day where Dave Stickler from High Bar Steel was talking about his view on green premiums, and I really think he's got the right take on it in terms of he does not think there's going to be much of a green steel premium, if any. What he thinks is it's going to be the tiebreaker. If he can provide the same product to the same customer at the same quality level as a competitor, they're going to choose his product because it's greener, even if it costs the same money. So it will help him secure his place in the market as the market progresses. And I thought there was a really good answer to that green premium. Hopefully green premiums do come, and hopefully that incentivizes more customers or to more steel companies to continue with the projects and helps them execute those projects.
Mm-hmm. And when we're looking at it right now, given all of this uncertainty, we have to look at different scenarios. Specific examples, we might look at the carbon border adjustment mechanism in Europe, and we'd look at a scenario where, maybe it's not that strong and doesn't support a green premium. On the other hand, maybe there's a situation where it's strong enough that it supports a premium for low carbon products entering Europe. So these are all things that we need to consider when we're looking at a specific project.
And I think some of the projects we're actually doing today are the same projects we were doing 10 years ago. We just didn't call them green steel projects then because they didn't have a specific target to reduce carbon emissions. They were being done because they were good projects to do regardless of carbon emissions. Now with carbon emissions, that just creates further incentivization. In my opinion, the biggest sort of single impact to people thinking about decarbonization was the signing of the Paris Agreement. And really, as that kind of sunk in, the impact that had on the investment community, pulling the steel companies and the resource companies and making them start thinking about and later developing their 2030, 2050 decarbonization roadmap strategies, with that 2050 one generally being a net zero target.
We've worked on a lot of these decarbonization strategy projects for iron ore clients, iron and steel clients, and others in the metal sector. And we always ask, why are you doing this? And it's interesting the range of answers you get. Sometimes it's as simple as Investor X told us we had to. Others might say, in our region, government has told us that the compliance costs are going to increase this much, and this means that our carbon pricing exposure is going to increase and we have to do something. Others are saying, it's a procurement requirement now for this place. Others see it as a competitive advantage. And a lot of this was sort of catalyzed at the back end of COP26, but you see it coming from policy, from customers, stakeholders, especially investors, and sort of also general response to reputational risks associated with being a big emitter and needing to have a plan to deal with those in the long term.
And that really exploded, I would say, in 2020. I think around that time we probably did about 50 to 100 different roadmaps for different steel companies. So really got in and understood how we could help and how we could not just say this is what we're going to do in 50 years. These are the steps we're going to take over the next 2 decades to reach that net zero target.
Yeah.
And do them at the right time where it makes sense to spend that capital.
Yeah. And it was interesting because at Hatch we did our first MAC curve for a steel company back in the early 2000s, and it was a nice little desktop exercise that sat on somebody's desk, I think. But since then, as Paul said, we've worked on so many of these assignments that are actually converting into real projects. Like many of our clients, we had to reorganize ourselves and put together a dedicated team that's focused directly on climate change.
Yeah. No, thanks for diving into that and touching. I mean, you two touched a whole range of different things, and I really like the way you put it, where it's a way of thinking and not just a product.
Yeah. And it's a way of thinking with a lot of controversial areas as well, right? It sort of begs the question, where should iron be made, right? And if you're looking at green steel, are we just looking at the iron making operation, or are we looking at the energy system? Are we looking at how the natural gas was produced, or how the hydrogen was made, and when the power, was generated to ultimately produce that steel? One of the very interesting topics here is, should green steel be different for iron ore-based steel making compared to scrap-based steel making? And that's probably a topic better left to the policymakers, but it's a trade-off between, encouraging more scrap-based steel making or, accelerating the decarbonization of the integrated steel route.
Yeah, no, that makes it really complicated to, I guess, decarbonize the industry, right? So we hear about Scope 1, Scope 2, Scope 3 emissions. Can you maybe elaborate on that a bit?
Yeah, so I think for those who are less familiar with those concepts, Scope 1, 2, 3 emissions are mainly for corporate reporting. Scope 1 are direct emissions. Scope 2 emissions, in this context, it's mainly about emissions associated with power for the iron and steel making processes. And Scope 3 emissions are those that occur up and down the value chain. So that includes the mining operations, transport, production of fuels being used, and then also downstream use of these of a iron and steel product. I think what's important for us to remember is that while that's a common framework for thinking about emissions, depending on the business objectives, they might be different. Right? If you're trying to meet customer requirements in the United States, you probably need to have an LCA and an environmental product declaration that has a different set of rules and a different set of boundaries. If you're looking at avoided compliance costs, you might be looking at direct emissions only, but also considering risks of sort of passed down carbon pricing from people that you purchase raw materials or energy from. So I think going back to my definition of green steel as part of the identification of the business drivers, you've also got to look at which emissions are relevant for the project or decision I'm making today.
And Scope 3 emissions have been really interesting for us, especially as it relates to the resource companies. Their Scope 1 emissions are really small compared to their Scope 1, Scope 2, and Scope 3 emissions. Because their product is used in a steelmaking process, and because that steelmaking process emits a lot of CO2, they have announced roadmaps to get to net zero by 2050, net zero Scope 3 emissions. One of the really cool things that's happened that certainly hasn't happened in my career up to now, are new companies are coming into the market, basically startup companies that see this as a business opportunity, that see producing, whether it's green steel or green metallics, as a niche in the market that allows them to enter, that allows the investment community to get excited and back those projects, and bring those into reality. And some of those projects, especially in Europe, are starting to gather pace.
And I'm guessing Hatch is collaborating with these startups and projects.
We've worked with some of those in the early stages and really helped them work through the project plan and get them to the point where they're able to fund the project.
It's interesting because there's a lot of new entrants in this space, whereas for a long time, you sort of knew everybody in the steel world down to like individual people. But with sort of these drivers to decarbonize steelmaking, there's players with a higher risk appetite, especially on the technology or product development side, that are getting involved. Some of these are companies that, maybe their interest was actually hydrogen rather than iron making. But what they found was that this is a really great way for them to make hydrogen somewhere and then ship those benefits around in the form of metallics, whether or not they make steel locally. So that's, definitely one area where we're seeing a lot of activity. The other one that's, sort of related to new entrants are a lot of these startups that are working on transformational, iron making processes for the most part. And we're working with a lot of those clients right now, bringing our expertise in process development, pilot projects, demonstration projects, scale up and commercialization. And it's also, very new space because there hasn't been this type of activity in iron and steel for a long time. A lot of these startups are motivated by climate more generally, and they may have come from, a energy background, wind, solar, batteries. Some of them even come from, the software tech space. And it's been really interesting working with them because their approach to creating something new is different. They achieve cost reductions through economies of scale, and for them, de-risking is different. And where we're finding that we can really help them is by bringing the background we have in, novel, first-of-a-kind, large capital projects to help them sort of de-risk these projects in a different way.
What are some of the risks associated with these new novel technologies?
It's interesting because they're very similar to, what we've gone through before in the metals world more broadly. Like if Hatch has a specific niche, it's, in my opinion, or at least from the world I come from, it's first-of-a-kind projects, and especially in metals. We've got huge pyrometallurgy and hydrometallurgy teams, and we've even written books about, what it takes to scale up novel processes. There's a couple of key learnings. One is, how you scale up. The other is around, integrating the process. You've also got to look at which pieces of equipment are new or novel, and the scale-up approach is going to vary depending on what you're looking at. But long story short, that what we've done in the past is really applicable in this, new iron and steel making world.
I mean, the other thing to touch on there is that these projects, the steel industry is big. Most of the other metals industry talk about thousands of tons. In the steel industry, we talk in millions of tons. These are massive projects. There isn't a project that's, or at least a big project that's under $1 billion. It takes a special skill set to implement those projects. And to be fair, the steel industry really hasn't seen this kind of development outside of Asia in probably 50 years. So the skill set to deliver big projects doesn't reside within the steel companies. We're seeing a lot of people coming into the steel industry from other industries like oil and gas, where they do have large project experience. So that's where, our teams, where we've been involved in big mega projects, over $1 billion projects, in other metal sectors, especially in the mining sector, we know how to deliver those projects.
Yeah. I'll give a specific example. One of the things that's really important for the decarbonization of hard-to-abate sectors is carbon capture, right? It's something that's, generally new in this sector. Hatch did, as far as we know, build the first commercial carbon capture project in a metals facility back in the 2000s at a nickel refinery. But this was actually because they needed CO2 for the process. But, besides that, there's not that many projects in this space. One of the good things is that, at least from the Hatch side, we've been working in SO2 abatement for decades. And a lot of these projects were, large-scale, complex, first-of-a-kind projects. And we're able to take that skill set and apply it both in carbon capture and carbon dioxide removal. For a lot of the challenges in this space, they aren't really about the carbon capture system itself, but they're more about how can you modify the process so that it's easier or more economic to install a carbon capture system. How do you design the gas handling and cleanup system so that you can send it to a carbon capture unit, and where are the sort of heat integration and other opportunities to make the overall system more efficient? So in those cases, we're not starting from scratch.
Can we perhaps talk about hydrogen? I know you touched upon this briefly before, but is that the solution?
Well, it's sort of funny because in climate, hydrogen gets a lot of attention for various reasons compared to other mitigation tools, and our general perspective has always been hydrogen is the worst option when electrification or other approaches are possible. That being said, in an iron-making context, hydrogen might be one of the most important ways to decarbonize the iron and steel sector. And if you remember to Paul's commentary earlier, one of the reasons is that, some iron is made using a direct reduction process today. So why is that relevant? Going back to novel metals process development, these things take 10, 20 years. In this case, a DR unit is a gas-solid reaction. It's natural gas with iron ore pellets. And it's actually not natural gas. It's reformed into hydrogen and carbon monoxide, which then goes into a shaft furnace for the reaction. This means that this process and this reactor is much more hydrogen ready than other things we'd have to develop from scratch. If you think about a blast furnace, that's not something where hydrogen is going to be a decarbonization tool to reach a net zero end state or near zero emissions end state because of the function of coal and coke in that process. But going back to a DR unit, that's well set up for hydrogen in the process. So it's...
I'll maybe add to that a little, Gino, if I can. I mean, there's already processes out there that use syngas. Syngas is about 50% hydrogen. So using hydrogen in today's technology, we know it's possible up to a certain amount. Fairly certain it's possible up to another amount. Where hydrogen, in my opinion, doesn't make sense is burning it. Using clean electricity to make hydrogen, to combust it, to make heat is really the worst case scenario. Why not use electricity to make that heat direct? Hydrogen should be used as a reductant, as a chemical, to do stuff like the reduction of iron ore into iron. That's really where the value of it is. It's expensive, so use it where it's absolutely essential and not a kind of nice to have sort of, we're burning hydrogen, we're super clean. I don't think is the best use for hydrogen.
Yeah. And based on the projects we're working on right now, they sort of fall into two categories. It's demonstrations and pilots that we're actually building right now, smaller scale, but often the intent is to de-risk the process or to get operational experience with hydrogen in a industrial environment. I'll carve out a couple other areas from Paul's hydrogen reaction. There might be some high temperature process heating applications where electrification just isn't possible at those temperatures. There might be some mobility applications where battery electric vehicles might not have the range for, let's say heavy haul trucks or other long distance applications. That being said, Paul's right. Direct reduction is one of the best applications for hydrogen.
Are there any other options out there? We hear biomass and the other options that your group's looking into.
Yeah, and it's one of those things that Paul alluded to earlier. There's no single solution for the iron and steel sector, and depending on the region, the process, the raw materials available, all of these things inform which pathway makes the most sense. Let's take an easy one, where you can do more EAF-based steelmaking. You should increase the size of scrap-based steelmaking, and that's existing technology, and that can be considered an electrification pathway. In some regions where biomass is available, especially in this case sustainable biomass, there's existing approaches that use biomass for making iron, and there's also novel technologies being developed, novel processes that would use bioenergy. And then the other one we touched on as well, in some regions, carbon capture will probably make more sense than hydrogen, and this is especially true for a transition from the integrated steel route to natural gas-based DR processes. In those regions where you've got natural gas, there's a higher likelihood that you have the geology that's appropriate for carbon capture and storage. So again, it depends on where you are, but we're working on projects in all these routes.
And I think region's a big deal, because there's large producing regions in Asia, such as Korea, Japan, Taiwan, China, where they don't necessarily have access to the enablers for green steel. They don't necessarily have a clean electrical grid. They don't have access to natural gas. They don't have access to sustainable biomass, and they don't have access to the geology for carbon capture. So what do? I think what we're going to see in the future is a decoupling of the steel industry, where traditionally iron and steel has been made at the same facility. We're going to see that decoupling of iron making and steel making, where iron making is really done in a location where it makes the most sense, somewhere that's got those enablers, somewhere that's got natural gas today, somewhere that can have hydrogen in the future, where iron can be made sustainably and then shipped to those steel makers in those countries, where they go ahead and make the products for their customers in those countries.
And I think that's this is a topic we've covered at conferences and is often discussed. And when you're looking at iron and steel decarbonization, you sort of look at what else has happened in the past in iron and steel. If you look at where DR units are located, it's where natural gas is cheap and plentiful. Right? If you go to other commodities, where's aluminum produced? It's where power is cheap and plentiful. If you look at where a lot of aluminum smelters are, they're where hydropower exists, or low cost power in the Middle East, that type of thing. So in the future, the most efficient system might be to make iron where you've got carbon capture resources or the ability to produce low-cost hydrogen.
No, thank you. Thank you for diving deep into that. As we're nearing towards the end of the podcast today, what is your one key message for our listeners?
Like maybe I'll start on that. And it's maybe not a key message, but a key takeaway. I've been 30 years next year in the steel industry. And this point in time and for the next couple of decades is really an exciting time to be in the industry. It's going to see phenomenal change. There's going to be hundreds and hundreds of new projects. There's going to be loads of new technologies coming onto the market, loads of new players into that market. And the thing about that is it's really bringing in young people into the industry who want to be involved in the steel industry. That traditionally hasn't been the case in large numbers. But now young people want to work in the steel industry. They see it as a way where they can make a difference and they can make the world a better and a more sustainable place.
Gino?
I think one thought I keep coming back to is that, emissions reduction now is, in many cases, more impactful than, near zero emissions 30 years from now. And I think a lot of climate-related projects rightfully get a lot of scrutiny, but sometimes it's to the point where we don't make any progress in the short term in pursuit of, carbon-free steel, which shouldn't be what we do right this second. So I think it's worth, in addition to novel hydrogen processes and novel electrical iron making, that we devote enough attention to, reducing emissions with the facilities we have right now in the short term.
Thank you for joining us on Forging the Future, Decarbonizing the Steel Industry, where we navigate the complexities of iron and steel. We hope today's episode has provided you with valuable insights into the sustainable transformation of the industry. Remember, the path to decarbonization is a collaborative effort, and every step counts towards a greener future. I'm your host, Takshi Sachdeva, and along with the entire team at Hatch, we appreciate your engagement and curiosity.